hold on, data collection is a good way to kind of analyze your process. If you're not creating a benchmark or a baseline, how can you understand where you need to go to perform and grow as an organization? Now, one of the things that I start you out with very simple is range, right? Range is going to be your maximum value minus your minimum value, right? Um, if I have, for example, and let's say I have some values here 13, 5, 12, 22, and 15, right? What would be my value in this situation, or what would be my range value?
The difference between 5 and 22.
Yeah, so we would have our maximum value minus our minimum value, right? What's our minimum value here?
5.
Five.
All right. So
17.
when I look at that, I have a range, which I can also look at as a spread, could I not? That if I looked at it from a data point, right? I had 0 and I have my data, or well, if I looked at, I'm sorry, maybe that's not 0. If I look at my center point here, right? I know that it's mu, and we can identify it as that, right? Your range, that minimum value, can also be known as your LCL, right? That LCL stands for lower control limit, right? Your max value, we can understand that as UCL, and we can identify that as the upper control limit. And we look at that, that's the tolerance that our process has, right? Anything outside of that, our customer could associate as waste, could they not? Because they're not within that range or that spectrum. Now, the range calculation, why is it valued? Well, when we look at our process, being able to see that specification limit, if I'm working in maintenance and I have someone that changes oil, maybe I want to create a good range of how long it should take to create a standardized process, right? As we look at range, it's one of the key metrics we can utilize. The functionality of range is very much like, hey, this is what it is. We can use this then to build off a control chart, right? We can associate range as also tolerance, right? My tolerance is my limit and my maximum value, right? I want you guys to take a couple minutes and we're going to do a little case study with Bridgestone, right? They, manufacture tires, but essentially we have their tires that they produce. I want you guys to take a couple minutes and I want you to create a range for this process. I'll give you guys just a couple minutes and then we'll come right back into it. It'd probably help if I was unmuted. You know, pretty easy. We're coming up here. We're setting up our range value, right? I can set this up as 150 minus, what is it? 120, 110, right? Come through. This then becomes 40, as that's the range of the variables, right? I kind of want to like get us like at least to this sense. Is there any questions or concerns about that calculation? Really straightforward, right?
Just curious, in this example, is it not important to include that it's only Monday through Friday, 5 days a week, not versus 7 days a week? Just because it's there?
No, I mean that was just a calendar of when they're producing parts. The format for it was already set up as a 7-day schedule. So, you know, really, if you don't see the parts, you're not producing anything. Right now, obviously, if we were producing parts on those days, we would want to take that into consideration. But we don't work on Sundays and we don't work on Saturdays. So, one thing that I kind of wanted to show you guys in this section, if you guys you're welcome to do it with us, but I want to show you guys how to do this in Excel because it's going to save you so much time, man. And we're going to be building like a little cheat sheet as we go along the way. We'll call this range. But I want us to kind of zoom in. And so we can say Monday, right? I know it's off. I'll fix it here in a bit. There we go. So I want you guys to get at least to right there. So when we build a range calculation, you know, what do you think is also another metric we may want to look at with range from a practical standpoint?
Median?
Yeah.
Standard deviation,
Yeah. So
mode.
we'll do it just a little bit slowly. Hold on. If I looked at these variables, right, and I'm still working on Bridgestone. Ooh, where's it at? There it is. All right. Somebody had said the mean, right? And so putting that in, right? I'm just basically building this slowly for you guys. But I would want to know what my average of that data set right away is from a statistical standpoint, right? I can do this several different ways. The way I'm going to show you is going to be more beneficial for you guys to practice through. But you have your range as, you know, your lower control limit to also your upper control limit, right? You may also hear me say specification limit versus control limit, still interchangeable. Just kind of FYI as we're hanging out. Now, one of the ways that I do this is by building a formula. And building in a formula is going to be really helpful for you in no matter what you guys have, no matter what you do. This is going to be helpful for you. So this class, you're kind of getting that added bonus of how to do data entry into Excel. I'll ask professionals, I'll ask them, I say, hey, I see on your resume you have, Excel experience. And they're like, yeah, I'm really good at Excel. And I'm like, okay, do a calculation of standard deviation of these data sets. And if they can't answer it, it's something that helps you out. So getting the practice, especially if you're going into quality management roles, it's going to be beneficial for you. So we'll come through and we'll build this in Excel. And our mean, we can do this several ways. You can come up here to the function button. It's really easy to do that. I prefer an easier method, and that's just kind of writing the formula in by going to equals average, highlighting that data, right? I'll leave it there for a little bit for you guys to see it. And essentially, you'll hit average, you'll say equals average, right? Double click that variable and highlight everything. Now, when I say everything, exclude Saturday and Sunday. If you have data there, it's not going to be beneficial for you. So when we do that, we'll hit enter, right? That means the average of our data set is, 130, right? Now, if I wanted to look at what my lower control limit is or my minimum value, I can do that in Excel by saying equals min, take the min of that and highlight it, 110, right? And I'll double click it so you guys can see the formula. But that lets me know right off the bat what's the minimum value of my data set. And my upper control limit, I can know this is my maximum value, and I say equals max. I'll double click that for you and show it to you here. Equals max of E1 to E5. And I'll hit enter. So as I look at this data set, I know what my mean value is, my lower control limit, and my upper control limit. One thing I'm also going to do for you guys is highlight this and give you guys the formula so you can see to the right of the screen of it, right? Now, essentially, as I draw out my, delete this. Essentially, as I draw out this framework, I have my control limits, right? And I also have, we called it our average. but we can associate it as our mu, right? This is essentially as a U with a teardrop. And so I've created the basis of a control chart, right? I can start to see my process a little bit, right? If I have my average, what do we say my average is? 130, right? I have my range of my lower control limit of 110 and my upper control limit of 1. Yeah. Right. Pretty basic, right? But it really starts to help us understand the foundational material we need to understand to go to, right? In this, a range, once we understand it, we can start to form a normal distribution. Well, as we're starting to see, we have these measures, and this is what we call central tendency, right? We identify what the central point of that data is, and I'll explain as we're going through, but I wanted to just make sure that we all understand where we're trying to go with this, right? So once we create the range, we can then create the distribution of that data. Any questions before I move on? All right. How are you guys feeling? Nervous? Like excited?
Nervous.
Don't be.
I'm having flashbacks from my statistics class that I took a few years back.
Don't say. Oh, man. But when you start to look at statistics in a like a more practical sense, right? I think it'll help you understand it. And hopefully through tonight's session, this helps you out tremendously. Hold on, let me get up in here. All right. So as we're looking right here, right, we have our range. It's, it spreads across a data set, essentially, right? We know that this is the variability in the process, the extent our process can differentiate. Why would you want to know a range in a data set?
You want to know your left and right limitations?
Right? You can kind of think of that as scope too, right? You want to know exactly where your process can kind of land. Understanding your variability brings awareness to it, right? And then if you see the variability in your process, you can control it using Six Sigma methodologies. Now, when we understand variability, right, the range provides essentially a snapshot of the dispersion in the data set, right? It helps us understand how spread out the data points are, which is a fundamental in assessing the performance and that consistency of your process, product, or service. So essentially, always get kind of used to, hold on, let me get some water. Look at that. Whenever you see processes, always get used to understanding them as this, right? Now, in the statistics community, I may get a slap on the wrist for this because not everything's a normal distribution, right? But as you'll start to see in the central limit theorem, as you collect more data and the repetition of it, normally it forms a normal distribution. But I want you to get used to when you see data, always understanding, okay, what are my left limits? What are my right limits? I don't exactly know what my distribution is, but you can see it as a bell curve, and that's okay for this course. I'm going to show you as we advance more other distributions and how to kind of look at them. But for the most part, I want you to associate all distributions as normal. Any of my statisticians in there, you're welcome to slap my wrist, but this helps them understand the data, especially when we go into confidence intervals. Now, why would we want to know a range of values? Okay, well, if I'm showing you a case study, for example, there's 2 slides I want to show you guys on here. But essentially, if I'm looking at Toys R Us, right? I kind of mentioned last week a little bit about it, or Tuesday, I believe, about it, but that's okay. But we understand Toys R Us went out of business, and a lot of it was because of companies like Amazon that led to a decline in revenue from people going to their brick and mortar establishments, right? Now, I use Toys R Us as an example because, I mean, I'm a toy collector of myself. That's what I love to do. So hopefully this is a good way to explain why we need to track our data or why we need to track our sales. If we're not viewing that, then we run the risk of going out of business or bankruptcy, and then that overall leads to losing employees and dissatisfaction of your organization. Tracking that and adjusting with new platforms, new times, and how we can look at Toys R Us as a case study, how we can look at Blockbuster is also a case study of why we need to be innovative and creative to solve industry problems. Oftentimes customers chose a different preferred delivery method. Therefore, it became a decline in sales, and that's what led to Toys R Us going out of business, and often other models, or you saw smaller mom and pop shops not being able to compete with such a global entity. And a lot of it was because they went through the process and the failures that organizations go through when they're starting. And they adapted with it, right? When we look at things like Blockbuster or Toys R Us, they're a reminder of how we can use historic events to drive our own performance. Later on in the course, we'll also talk about Volkswagen and their emission scandals and how upper corporate leadership can, also use this to make effective decision making in an organization. As Six Sigma professionals, we're here to look at processes and look at different ways to improve the organization or the process. A lot oftentimes will come with issues but not the solutions we need. So when you talk about the missing link and I tell you about data collection, you guys won't have this file. It's okay. But I wanted to show you guys, you have your central limit theorem, right? When we approximate the mean by employing multiple repetitions of data, we can understand our central limit theorem, right? Not everything's a normal distribution, and that'll be the last time I say that. But I want you to associate your data as a normal distribution. when we go and talk about statistics at its core, we want to understand our data just a little bit more, right? And so there's two types of data that I talk about in this course, right? We have descriptive statistics, which you guys are going to spend a lot of the time working on your project, putting these graphs together that relate to the deficiencies in the organization, or we'll practice as we go through. But your descriptives are going to be used to summarize and describe your data, right? It's to provide a clear, concise summary of the data you have at hand. So essentially, a pie chart is going to be a good representation, or a bar chart. These are descriptive, and oftentimes they relate back to central limit theorem. The descriptive statistics that I want you to use in your project go as follows, right? And we're going to build as we go through, and we'll use that Bridgestone case study as a way to kind of help us build this. But your descriptive statistics are a way we can use data as a driving factor of why we need change in an organization, right? When you talk about pie charts, bar charts, and scatter plots, they oftentimes become a focal point for us to understand our data. And it gives us a glimpse, and it also shows our audience why we need to have a change happen. So what I want to do, this is just an example, but I want to show us how to build this in Excel, right? We're going to use Bridgestone as an example versus this example. This is for a different class, but I wanted to show you, right, how to build a pie chart. Essentially, I already have all of the data I need in this category. Maybe I can highlight some things, put some borders around things, a little bit clearer for you guys. But if I have my data set here, I can collect and create a pie chart, right? The way I can do that is by going through highlighting these values Monday through Friday, and what is it, 120 to 140, going to insert. From here, I can create a pie chart. So I'm highlighting the data, right? I'm not really including Saturday and Sunday in this example because it serves no purpose for us. And I put a 2D pie chart together, right? You can use whatever example you want, but typically 2D or 3D pie chart are what's going to be relevant for you. Now, let me ask you guys, is this in a practical sense, does this chart mean anything to us at this point?
No.
Because
No.
it all kind of looks the same, right?
Yeah, just identifying the date.
No, it just,
Correct.
yeah, it's not, yep.
So as you're looking at it, right, what would be more of an appropriate chart you would use in a real sense?
You
Probably
use
a bar chart.
Okay. So I'm going to just leave that as is, right? Monday through Friday, boom, insert bar chart. I haven't talked about Pareto yet, or have I? I think I have. Yeah. But a bar chart or a column or cluster might be a better representation of that data, right? I just say that from a practicality sense because a lot of times people will come up with a pie chart and it's like, okay, well, what are you trying to show me here? All of these look relatively equal, right? Well, maybe a bar chart would be more of a better way to influence my decision, because I can see right off the bat what's the highest value on what day.
Tuesday.
Okay, so Tuesday, right? Think about this from a managerial level. What are some best practices going on Tuesday that aren't going on in other weeks, right? If you guys go through and think about that, well, there may be more managers on that shift, or maybe it's a production flow issue where maybe the machine gets a new blade on that day, right? And so you can produce more parts or whatnot. You can look at it from an efficiency standpoint as well. If you guys could go ahead and make sure you're muted, I greatly appreciate it. Thank you. So as you guys are going through and you're looking at this, right? We've gone through, I've created a pie chart, right? I've created a bar chart, and I'll just show you guys that again as we're going through. I just highlighted the data. I went to insert. I then went to the first left column. I then created that bar chart, right? I like vertical. That's a preference of mine versus horizontal, but it's totally up to you. So as you guys look at this, Quan, I got your message, dude. Thank you. That means so much. The last one I want to talk about with you guys is a scatter plot, right? Essentially, remember I told you when you understand your lower control limit, your upper control limit, and your mean, that's the basis of a control chart, right? Well, essentially, I'm going to highlight my data. I then create this scatter plot. Right? I'll go through it again and just so you guys can see it. Maybe that was a little bit too fast, but I'm going to highlight Monday through Friday. I'm going to go to insert. I'm going to come over here to say insert scatter. You're welcome to use any of these. I prefer scatter, or I don't know what this one's called. Scatter with straight lines. Well, you can add, yeah. But this becomes essentially a baseline to your data collection, right? I can see, okay, well, where is my average in this data set? Well, maybe I want to add it in here. Well, it would be somewhere around here. What's the deviation in our process? Well, we can look at that as we grow here too.
You asking us the 40, the deviation of 40?
I wasn't really asking a question, more say I was just kind of showing you the purpose of building this graph and how you could use the mean to kind of understand the variation. And that's where you were going with it. I love it. Thank you. Is there any questions about this per se, or any particular kind of question of why we did it a certain way or anything like that?
Hey, Zach, I got a question. It's Quan.
Hey, Juan.
Hi, if I'm in here, what, like if I was in front of, my leadership, executive leadership, what is more recommended for them so I can get my point across? Would it be the bar chart or the scatter chart with lines?
Well, dude,
Depends on
okay,
the-
I would definitely say bar chart and scatter plot, but it also depends on what type of data you're showing, right?
Exactly.
It's kind of hard to say, like, you know, if I'm showing a profit loss, I want to put everything in red and I want to show it as like, you know, hey, we're losing this amount of money. Or Joseph talked about, you know, essentially the cost of poor quality earlier, right? And, you know, maybe we don't have that data here with this Bridgestone case study, but I can at least show, okay, there is definitely a flux in production. Oh, sorry, guys. I didn't realize the water bottle was by blocking my face. Thanks.
Yeah, I guess maybe another chart is where you have two lines on the chart, and one shows like the progression, and another one is showing, you know, a time where you were, you know, trending downward or something.
Yeah, let's say, you know, we look at it and we say, this is probably a really cool example, and maybe I can show you this as a way to kind of wrap our head around what we're trying to do. But essentially, let's say we're trying to balance out our operation a little bit, right? So we have our before metric, right? Or what we know as current state. That current state is, you know, essentially the current state of our operation. Well, we also have something called a future state, right? And let's just say we did a process, a continuous improvement process, and we were able to kind of more balance this operation, right? Maybe we were able to balance it like this. I'm just choosing random numbers, but to show the purpose in the charts. So if I was to highlight this data and do a bar chart of the production flow, right? And I was to do an after effect of it, saying, hey, we stabilized the process more and we were able to create a better output that's more evenly distributed, right? Maybe we could do the exact same thing. And you can see a more, I guess, a closer stabilization, but maybe that's not the best chart we want to do, right? So maybe we might want to use a control chart. I'm doing the first area right now. Because maybe we want to show what the dispersion is, right? And I haven't taught standard deviation yet, but that's where we're going with it. I can show a more aligned process with a scatter plot, can I not?
Mm-hmm.
So in this, you can understand why you would want to show a current state of your operation and a future state. And, you know, that's what you're showcasing when you talk about continuous improvement is showcasing what the future value is, future state. Right. And so,
Exactly.
yeah.
I was gonna say real quick, wouldn't it be better if you combined them? I know for me, if I had both and like different, like current was blue and future was orange, I think it would paint a better picture or an easier picture to understand the differences if they
Yeah.
were in.
Yeah. I just wasn't going to go through it.
I know how to do that, but I
Yeah.
just for the
Like doing the oh, here we go. Here we go. Oh, okay. I'm not gonna do it for everyone, but you guys could play around with it. But the understanding the
I
Yeah,
was
difference.
that's
they were in the same exact they were in the same exact chart, but you see where you have like Monday, if it was Monday blue right next to, or Monday current,
Oh, okay. Okay,
Like-
so I see what you're saying. So if we showed it this way too, hold on. I know what you're saying. I got what you're putting down. So we're gonna highlight these variables, put them in there,
Okay.
and then just have one chart of before. Let me,
Yeah, and it'll show both data points side by
Right.
side.
yeah, yeah,
Makes
like
it-
that. Before, after improvement, right?
Right.
Yeah, there you go.
Yeah, exactly. That's what I'm talking about.
Yeah. Way better. Way better of a way to describe that and show it. And you can do the same thing with a scatter plot too.
Yeah, if you click on recommended chart, you can kind of just scroll through all of them and see what they look like before choosing.
Yeah. I'll let you guys play around with that more. But it kind of gives us the purpose of why we would want to show that flux and the variation in our process, right? So there's some additional, ideologies I kind of added to this that I may have not have gone more in depth with, and I want to add to it. Your current state is going to be the current state of your operation, its metrics, its performance. And then your future state is typically associated as your after improvement. Any questions about what we talked about up to this point? I think everything's been pretty straightforward, right? Like maybe you've got to play around a little bit with graphs. I think having that Excel prep yesterday helped you guys for this, so I'm really glad you guys took advantage of that. I want you guys to create a new tab here, right? Just go ahead and create it. We'll come back to it. But what I want to do is I want to take everybody, I want you to take a 10-minute break and then come back and we'll go back over this. And we'll move on to the next topic. Okay. So one of the things that I want to talk about with this is when we're looking at our process. Hold on. We use qualitative data to understand our customer, that voice of the customer, right? Because some of those things may not be quantifiable, but they could be over time, right? Like what's an example of something that could be not essentially a quantifiable category, but it could become a quantifiable one over time? This is where you could say something such as, go ahead, Marianne. Oh, I got you. Hold on. I got it. Go ahead, guys. Go ahead, Marianne. It should be unmuted now. Hey, are you guys still there? I just want to make sure it didn't get
This is Charles Schneider. I'm still here. I hear you.
Yeah, still here.
all right.
Yeah.
So You know, an example of something that could become that is qualitative but can become quantitative over time is like a choice of color in a product, right? That then becomes consumer data we can utilize to kind of make customer based decisions off of, right? You know, we talked about descriptive statistics. You know, we can use that qualitative data. We can make pie charts off of that. What's the recommended color of our customers? Go off of that to make decisions. And we can also use measures of central tendency. We've talked about these already, but we have mean, median, and mode. And you also have measures of variability, such as range, which we just learned about. Standard deviation and variance are coming very soon, but I want to progress us to that point. So, as we look at descriptive statistics, one thing I want you to take a note that the more valuable, the more data you can collect, the more accurate representation you can have. And I'm pulling up this slide for you guys. Give me just 1 second. There we go. So one of the things that I think that are very crucial for us to understand is standard deviation, right? Here is the formula that we're going to utilize. I don't like how I drew that E. Give me a second. Right? Now, I want you to associate this formula as standard deviation, but it's more of sigma. And so if you see this collection or where it says N-1, that's going to represent your degrees of freedom. And we'll talk about that down the road. But for right now, I want to go and just have this basic calculation kind of figured out. So one of the things with standard deviation is it allows us to understand our range, but the space in between it, right? And we talked about this in the Z-score video a little bit, but your standard deviation of a smaller sample size is known as sigma. And the reason we use that N-1 is because it gives us more of an understandability of our process. But we'll work a little bit of an example out here. Give me just 1 second and I'll set it up. There you go. So let's say I'm taking that range. No, maybe that range is a little bit too big. Let's do just some random easy numbers. But let's say 5, 4, 3, and 1. Right? Well, the first thing that I want to know out of this data set is going to be what is my average, right? We can associate this as also X bar. But essentially, we have X bar equals what? What's going to be my average of this data set?
Zach, I hope this equation is not on the test.
It will be, but I'm going to show you an easier way of doing it. Yeah. Right.
Just
So
remember, I'm an infantryman.
it's okay. But like, I mean, like, all right, can we be real? Can we have like that real conversation real fast? All right, if you come to me as a quality manager that's going to be looking at me, that's going to be representing my organization for quality management using statistics, saying that you can lead this process, right? Why would like I pay you? Why would I not find somebody that would want to learn this stuff, right? So it kind of like, I know it's like zing, that stings a little bit, but it also encourages you too, right? I don't do this in real life. I'm just showing it to you, but I don't do this in real life. I'm going to show you the other way I do it, which is going to be super easy. So just a little bit of growth there, right? Sometimes growth is going to be hard and it's going to be challenging, but it's rewarding at the end of the day, right? Here we go. Get off my soapbox, right? I've got 4 little brackets, right? Okay. I know that's 5, 4, 3, 1. What's my average here, guys?
3.25.
Yeah.
It's crazy. I just learned all this in algebra and it went in one ear and out the other, and now I'm learning it again.
I know. Man, I'm gonna be honest, I hated my like so like going through upper graduate statistics versus like undergrad. I learned more actually in the industry about statistics working as a quality manager and then like naturally progressing through Six Sigma. But like it it became like almost second nature, right? And like I remember like when I first started out, general statistics was so hard because it was so broad, right? You're learning about all these different things instead of, I like about the Six Sigma approach to it is you're learning about it in practice, right? Like what is the purpose of this? Because I think that becomes more valuable than how do I calculate this, right? So as we're going through, right, I've got this set up. Let's go ahead and solve these 4 equations real fast. Help me, help me, help me. Help me accurately though. Like I hate it when students give me like the wrong information and I'm recording and it's so embarrassing. All right. 5 minus 3.25. What do we got there? Was that
1.75.
7.5.
All right, 1.75. All right,
0.75.
0.75, yeah.
0.75. You guys are great. Thank you. 3 minus 0.3. So like would that be negative
Negative
0.25?
0.25.
All right. 1 minus 3.25.
Negative 2.25.
2.2.
Negative 2.25. Oh. You know what? I forgot one little thing right there. My bad. So, add the square to the formula. Somebody had messaged me and I didn't even see it. So the X observation minus the average, square that, right? So if I was to come over here with my squared calculations, right? Right, I have these, I have these squared calculations over here that I'm going to square real fast. So what's 1.75 squared?
3.06.
Say it again. What was the equation?
So if I'm trying to square
Yeah,
1.75,
3.06.
right? All right. If I have 0.75 squared,
0.56.
0.56.
0.56. All right. Negative 1.25, or I'm sorry, negative 0.25.
Negative 0.06.
So it's not negative.
Negative times negative is positive.
So what would
Right.
it be?
0.06.
Okay. And then one more, right? Negative 2.25, and I'm gonna square that.
5.06.
What did you say it was? Negative
Oh.
2.25 squared equals what?
506.
0.06, right? So what we've done essentially at this point is erased this formula right here. If you guys can make sure you're muted too, appreciate it. All right. So as I'm going through, right? 3.06, 0.56, 0.06, 5.06. That's what this is saying. This is saying the sum of these equations, right? So when I add these values together, what do I get? When I add these values right here,
8.74.
what do you get all together?
8.74.
8.74. Is that what else you guys got? Verify that, guys.
Yeah, that's what I got.
Okay. So as we're going through this, 8.74, that eliminates that value right there. So I'm left with essentially, it says n minus 1. What's my n value? What do I start with right here?
Your average.
So your n's going to represent the number of values.
4 minus 1.
So we got 4 minus 1, which I'm going to go ahead and save us and just do 3. Right? Let's go ahead and get that average or that value figured out. 8.74 minus, or 8.74 divided by 3.
2.91.
2.91. All right. So now we're left with the square root of that. Square root of 2.91. And I think we can we'll round to the 3 decimal points.
Is it 1.705? Is that what everybody else got?
0.075. Is that what you got?
1.705.
1.7.
Yeah, that's what Google's telling me.
Oh. Let me check it out real fast. Ah,
I agree. What for n, is it, do we do that for each value? Or is like, why did you pick 4?
because
be
how
the-
many numbers did we start with?
Oh, 4. Okay. I thought you pointed to the number 4 in the value set.
Uh,
Got it. Got it.
all right. So trying to open up this cheat sheet real fast. All right, let's verify our work now, okay? And let's make it a little bit easier for us. You guys want to go ahead and open back up your Excel doc? We'll call this standard deviation. Okay, standard deviation, kind of fun. But we're going to start with our practice questions, right? What was our values again? It was 5, 4, 3, 1, right?
Yes.
So as I build this, right, I can say Sigma calculator, or I'll call it underneath it. Right. As I go through and I do the Sigma calculation, right? I have my variables and I can say standard deviation of a sample. And I can highlight this range of values right here. I'll let you guys get to it. So go ahead and get that sigma value taken care of. We're going to input the calculation, input the numbers. This should be on a separate screen, so a separate tab. We'll call this standard deviation. Okay. So I'll add the formula to the right. But this allows us to standardize our practice, right? Standardize our formulas, our equations, because as you can see, we had a little bit of technical difficulty or maybe that writing difficulty. Think about that as you're assigning roles to your staff or the people that work with you on assignments. You know, that ambiguity or vagueness could create variation in itself. So as we're looking at this, you know, I try to use Excel for a lot of this stuff because you can standardize your practice.
Really quiet.
So I just wanted to give you guys time to kind of input this into it. Go ahead. Any questions?
You know, we were just worried you were gonna put that music back on.
I'll do it again, man. I'll do it. I think I got another one this time. So
Zach, can you show what your deviation formula, your deviation function is connected to?
oh yeah. So I highlighted the color so you guys can see it better. But that's what you would highlight.
Gotcha, thanks.
Yeah, no problem. Any questions about this? Excuse me.
Hey, Zach, what exactly do we need the standard deviation for again?
So when we think about our process, right? Like let's look at the range real fast, right? We talked about that control chart of these tire manufacturers, like how the tires being manufactured each day, the variables, right? Well, what I'm doing with standard deviation is I'm letting us know what's the space in between these, right? What are the space in between these variables, right? Why would we need to know that? Because that degree of space allows us to kind of, maybe we can constrain that process to improve it using that as a statistical baseline, right? So like essentially in a nutshell, I'm trying to find the space in between the variables so I can minimize that space.
Gotcha. So it's like a buffer. I got you. It's your window. I got it.
Yeah. Like you're trying to shoot that golf ball and get it as close as possible. Right? Well, you might ask, like, okay, as we're looking at this, if I'm trying to improve my process, maybe I want to combine both aspects of this, right? So let's try this, right? I'm going to create a new sheet, right? I want to call this sheet essentially golf collection data. So as I zoom in, let's say my whole like number of strokes, right? And we'll go down, we'll just do 9 holes. Go from 1, just drag it all the way down to,
You gotta type like 2, 3, and then drag.
okay, so I thought that too, but I found this lady showed me this last class, and it was like, oh man, I didn't know that. So if you come over here to the bottom of it, right, and I just type 1 and fill it in. If I go over here to that little box and then I say fill series, I'm like, oh man, I didn't even know you could do that. So it's cool how I learn stuff from students sometimes too. As I go through, I have the number of strokes, I guess, right? Right. I think I can just collect this and just highlight it and put it in the chat box for you guys too. I think I can do that. Hopefully that works. All right. So I'm looking at my number of strokes, right? Well, one thing I would want to know in here is maybe my total strokes, right? Is that what we would call it in golf, I think, right? Or we can say total score, right? Total score. And I can have a formula in here, and it helps us collect the totals, right? So I can say equals sum and highlight those variables. Right? So as I'm looking in here, right, I have my number of data, right? I have my collection of data I have. I have my number of strokes in my golf game, right? So from this, this automatically becomes my baseline for my next game, right? I can continue, I can improve along that way, right? So let's say I want to put together my everything I've learned up to this point. So I would have my range. And how do we calculate the range, guys? Let's look back.
X
Highest
minus.
minus lowest.
Uh-huh. So we had to calculate the mean first, right? Well, we calculate the minimum value. We have that minimum variable. All right. I also have my maximum. Right. And just to help you guys out too, I'll put the formulas right next to it. Okay. I know my minimum value is 3. I know my maximum value is 5. Well, from there, I have minimum, maximum. Maybe I want to look at average. Right? What was the formula to calculate average?
Total of all numbers divided by the numbers divided by the number
Yeah.
of numbers.
Yeah.
Equal average.
Exactly.
Right. All right, that was my data and my data collection, right? Pretty basic, pretty easy, right? Well, if I have essentially my first session, right? I can improve or not be good on my game, right? I could, improve or get a higher score, right? And so we can use this data to understand process improvement because we can relate it to our process. This is the diameter of certain data, or if we're making essentially like a cap, the circumference of it, it can become a baseline measurement, and we can make sure that our process or batch of data doesn't have much variation. Let's take a 5-minute break and we'll come right back. You guys are ready to kick things off. I think we're right there, right? So far up to this point, we've talked about range. We've talked about lower control limit, upper control limit, the mean. We talked about, kind of basic data entry and descriptive statistics such as, control charts, pie charts, scatter plots. We then went from a scatter plot to talk about the space in between. We then talked about standard deviation, right? That standard deviation then becomes a metric we can utilize to understand the space in between or the variation in our process, right? We then collected some golf data, right? And I had the number of holes that I had, right? I probably should have stopped at 9 holes thinking back now, but that's okay. We had 10 holes. It was a weird course. And then I have my data here, right? This is the number of strokes in my data set, right? I have my total, which is going to be the sum of my calculation. I have my minimum and maximum variable. I also have my average.
Somebody.
So this allows us to look at our process and say, okay, I can take this thought from golf collection data and then turn it into real data that we can utilize, right? So I have my average here, right? There's one more variable I want us to use to calculate it, and that's standard deviation, right? We'll call it sigma value. But I can type it as dv.s and then highlight my variables. And I'll just highlight that again so you guys can see how I set that up. I built the formula and then highlighted the number of golf strokes. Hey, what's up? You should be unmuted now. How can I help?
So I have a question. So the range, where does the range fit into this? I understand the minimum and the maximum minus that gets you the range, but is there any, do we
Just so
need
you
to do
can know
anything
what
with the
the
range?
tolerance is. Like, I'll get to it a little bit later when we start talking about variation in our process, but like think about like your pizza sizes, right? I would want to know the range if I'm putting it into a box, right? Or the customer specs in their different pizza sizes. Does that make sense?
Yes, I was just curious if they have a play right here. And
I mean, as this and as you're kind of understanding the data, I mean, you could do the range, but it's in this variable, it would be such a small tolerance window that I just kind of didn't really even put it in the calculation, right? Because as soon as we do the standard deviation, that becomes a pretty small number, right? And so the range, if I wanted to put it in here, right? I'll just highlight it as yellow. But we said that the range, how do I get the range? It's the minimum versus maximum, right?
yes, so it's 2. Yeah.
So 5 minus 3. So a range of 2. That becomes my tolerance window, right? You know, if I want to say, okay, you know, I want to improve my golf game. How would I look at that? If I want to improve my golf game, I want to try to take off the number of strokes. So maybe I want to reduce it by 1, you know, up in here, and we can use that as a variable to understand. Now the range per se, it helps you understand the whole variation. So like if we looked at this control chart here, I could see from this area all the way to whatever the highest variable is, or from this variable to this variable and everything in between, right? I can use the golf data to do the same thing. Even though the variable isn't as wide or large, it helps us see it from a different perspective because we can see that overall process, and that sigma value lets us know how much the variation or how much it variated in between. I can look at this now and say, okay, well, if I indicate my average, right? And I'll draw it out here. But if I say, for example, if I have a distribution, right? I can say the beginning variable is essentially 4.1, right? Or I'm sorry, beginning variable. The average variable is 4.1. Okay. I can then look at it and know the space. So 1 sigma make just a little bit smaller so you guys can see that. I've got 2 sigma. Oh, there we go. 2 sigma and 3 sigma. So it's not a 6, it's actually like that. As I look at this, right, I can say that that sigma value represents the space in between these variables, right? That range is going to be from my lower control end, right? Well, I'm going to change color. Lower control limit, LCL, UCL, right? I know that that essentially is going to be my tolerance or range. I know with my minimum value being 3 over here and my maximum value being 5 over here, right? As I can look at the variable and space in between it, I can know this as later on we'll talk about, you'll learn in the video if you haven't already learned it, it's the empirical rule. But I don't want to overwhelm us exactly just yet with that. So as you're looking at this, right, we have our average, which becomes essentially our 0 point. Our 0 point. And then you have your sigma values, right? And so what this does is this helps us translate any type of score we have to a standardized process. So, you know, for this example, we're talking about the number of golf strokes, right? Well, when I talk about different variables, right? I know that my range is going to be 2. I know my average is going to be 4.1. And I know my sigma, or the space in between, is going to be 0.8756 between each sigma value, right? And so this gets us to our beginning phases of understanding data collection. And as we go through the course, we're going to dive more into, okay, we have this basic data. This is what we need to know as a basic Six Sigma professionals. We're then going to learn about performance, such as, okay, if we have a defect in an organization, how do we improve it? Right now, we're right at a good stopping point for class tonight. In the next lesson, we're going to talk more about putting this more together in regards to defect percentages, probability. You're going to learn about that in the videos throughout the week, right? But these are going to be, we're going to start the lesson and making sure we understand those metrics, and then we'll move on to value stream mapping next week. So I want to just thank you guys for attending this session tonight. I hope it was really helpful. I appreciate you guys stopping by and hanging out with us. And I've got a couple minutes before I got to clock out. But yeah, I'm happy to help with anything you guys got.